Okay. Just by way of preamble and a little bit about the title of this session, this time last year, Richard was trying to get sessions together for the PowerShell Summit out in the States, and I'd just been dealing with some family issues, and Richard dropped me a note and said, "Are you going to put a session in?" And I said, "Oh, I've been up to my eyes with dealing with funeral arrangements and what have you, and I can do a kind of DevOps notes from the field based on what I'm doing at the moment." So this thing was penciled in as DevOps notes from the field, and then the title kind of keeps growing and growing. So it nearly ended up called something like "How I Learned to Stop Worrying and Learn to Love Scope Creep," or various other things. But I think for this one, it's going under the title of "How I Built a DSC Monster and Lived to Tell the Tale." And that's really what the session's about. It's about DSC and some notes from the field. I'm James O'Neill, as it says on the slide. Various ways of getting in touch with me on there. You can find my blog, you can get me on Twitter, you can email me, and I've started putting the address of my GitHub on there. Eventually some of this will make it into being shared through GitHub. Now, at the moment, I've actually got a little piece of configuration running in the background. I'm going to just exit out of the slides just to show you what's running. We have a virtual machine. Oh, and I timed that just perfectly, just as it reboots. In here, I'm creating a new virtual machine, and there's some PowerShell script running to actually do that creation. So you can see it said what it's actually putting into the virtual machine image. So it mounted a virtual hard disk, copied a load of stuff in, and the first time Windows boots, it's going to kick off some configuration and the DSC stuff that I'm going to talk about. So that's all going on in there, and you can see it said it booted for the first time here, and it's keeping me posted on when it reboots. It's going to reboot at least once more, and it's going to take about 15 to 20 minutes minimum, depending on how hard I'm actually working the machine from PowerPoint. Sometimes it takes a bit longer than that, so I just start that off and we'll see where we're getting to. So that machine's actually booted for the first time, and you can see I just fiddle things. So on the write progress here, I actually put the percentage CPU utilization so I can tell if it's doing something or nothing. That's usually quite a good indicator, I've found. So let's pick up from where we were. So that's going to run during the session. Now, this is billed as a notes from the field session, and I was talking about the roots of this session a moment ago, and sharing a bit of family information. So I'll share one other piece of family information, and that's that I'm not even the top computer geek in my family. My sister is actually a professor of computer science, and you can tell we get on really, really well. And she has this quote that she likes to tell her students, okay? Don't just expect people to be interested that you did something, okay, because they aren't going to be. So the point of this session is not, hey, I did a load of stuff with DSC and I built this stuff, etc. It's to try and show some of the things I learned along the way, some of the holes that I fell down. I'll show you some bits of code, and those of you who are really picky about the code will probably see some ways that it can be improved. Yes, I can see ways it can be improved too. But I'm actually going to show you some of the stuff that we're actually using for real. So, and what's building in the background is something that we really, really do use day to day. So, proper agenda. A little bit of me talking about DevOps landscape, some observations, then the specific problem that I was brought in to solve in the organisation where I've been for the last few months, how we went about solving it, and the lessons learned. That's really, the classic bit of a notes from the a good notes from the field session. And one of the challenges that I keep meeting in organisations that I go into. My background, by the way, is I spent 10 years working for Microsoft. I sometimes say I served 10 years in Microsoft and make it sound like it was a prison sentence. And then after Microsoft released me, I've been in a bunch of other places, including one quite interesting place. I did work for the Mercedes Formula One team for a while. And organisations that I've been in since leaving Microsoft, I've noticed it's sometimes quite difficult to get people pinned down on what are we delivering here. Be really specific. What is it that we're delivering? Oh, well, it's woolly. Okay, and who in the organisation is consuming these services? Now you've got me pinned down. I just mentioning the Formula One team. We did some discovery work and we found that some servers hadn't been patched recently. And I found a file server that was missing some fairly important patches or so, I thought. And I said, well, we need to patch this file server. Oh, said one of my colleagues, you can't patch that one. Why not? Well, we don't know who's using it. Okay. If we reboot it, then we'll see if anybody screams. And we can reboot it like midnight on Saturday night. Nobody will know then. He said, yeah. He said, you saw that really complicated piece of machinery on the factory floor that takes a big piece of metal and grinds it down into something little and fancy. It takes about a fortnight to do some of those. And we've got 2 of them running at once, and they're the left and right ones to go on Lewis Hamilton's car next week. Now, if you reboot that server, and it just so happens that one of those machines is using that file server, you'll be responsible for those parts not going on the car. I said, what are the odds? Well, you can take the, okay, no, we'll leave that. That's what I mean about, why don't we know who that file server serves? Well, it's just been lost in the mist of history. We don't know what we're using to deliver some services. We don't know what state things are in. The amount of discovery I have had to do about Active Directory state, server state, patch state, services state, etc., over the last few contracts is unbelievable. And we don't know the steps that people took to get it there. So heaven help us if we want to reproduce it. That's kind of an issue. And there are reasons that underpin all that. We always think we can do things really, really quickly, right? And then a bunch of things come along that say, oh, you can't do that. You can't do it in the time that you set aside for doing it. So we'll get the visible things done, right? So we'll get this server in and we'll get it serving whatever it's supposed to serve. We just won't write the documentation because we'll have a chance to catch up on that later. We should have a spec for doing this, but you know what? We all know what's being done. We won't write the spec down. You've all seen these, right? Sometimes it comes about because we've outsourced things to vendors, and the knowledge of how the system works is then lost to the organisation. So one of the contracts I worked on, I was working for one of these outsourcing vendors, and we were looking after a very large oil company, and basically they'd put Active Directory in the hands of one organisation, Link in the hands of a second organisation, and the network in the hands of the third organisation. So when Link didn't work, the users said, Link's not working. And we went, oh, Link's working perfectly. You just can't connect to it. It's a network problem. And this got bounced around between everybody. And of course, the network people didn't know what the Link requirements were. The Link people didn't know how the network had been configured. The Active Directory people were caught in the middle, and they didn't know what anybody was doing with anything, and so on. And then, of course, you've got problems with writing things up. I've not found who said this originally within our organisation, but it's become the excuse for why nothing is written up. Oh, we're agile, we don't document anything. And I've found that one or two organisations will use agile as a sort of as a label to justify being chaotic. Okay, this isn't chaos. This is agility. No, no, no. I know agility when I see it, and I'm not seeing it here. What I'm seeing is something that's chaotic. So we're missing the minimum set of information. Now, I can come along and I can automate things and make everything faster, right? That's what I do. That's what I've been good at for years and years and years. The problem is that if you automate a mess, all it allows you to do is create a bigger mess in less time. So I've got to make things better, okay? So it's not just a question of automation, okay? You hear people talk about infrastructure as code, right? So we should capture what's there, hopefully why it's there, how it got to be the way that it is. I'll show you that I've actually got quite a lot of stuff in Excel. Anybody not work for an organization where you use Excel? Right? I've done quite a lot of work, and if you look at what's been gone through my Twitter feed, a lot of it is to do with a module for hooking up PowerShell and Excel. I didn't originate it, but I'm one of the main contributors to it. And I kind of like infrastructure as a spreadsheet. Okay, so I will take things from people that actually describe how servers should be, and they give me a spreadsheet because that's what they think in. I then process that spreadsheet and I go, okay, so this server's supposed to have these bits, and I build it accordingly. Then when I've finished, I produce a spreadsheet for that computer that says, and here's how it is now. Oh, and I can redo that audit and compare how it's changed over time. Now, all that should really go into some other big inventory system. The problem that we have in the organization where I am is we're part of IT, and yet we're not part of IT. Okay, we're a project team that's delivering a particular thing into the business, and although we nominally sit within IT, IT doesn't do anything for us. IT actually is kind of a handicap for us, but I don't want to dwell too much on that. I haven't said who the organisation is, but I'll get to that in a second. And they wanted everything to be repeatable. That was the key, and why is explained on this slide. So, I'm working currently at Jaguar Land Rover, Britain's biggest car manufacturer. They've overtaken Nissan as Britain's biggest car manufacturer. They are putting in what they call a MES system, and I have to emphasise this is spelt with one S. And it's a manufacturing execution system. The way I describe it is it's computers that sit beside the production line and explain to the people building the cars, this is what needs to go on this car, and this is why it's different from the next one down the production line, and it captures who put the radio in, what settings were used for the machine that bolted the wheels on, and so on. So we've got information so that we can build exactly the car that customers ordered, and we have history information so that we know if a wheel comes off a car, it might be that that wheel wasn't bolted on properly, so we want to find all the wheels that were bolted on with that particular tool. Okay, so that's what a MES system is. And we have to install this quite complicated stack onto either servers that have been built for us by our friends in IT. I say friends. I'm probably not allowed to. No, we won't go there. But these are built for us, or we have to build a number of test environments. Now, those test environments might be completely self-contained. So they've got their own domain. So we've got to build a domain controller. We've got to build SQL Server. We've got to build either individual servers or clustered servers that deliver this MES service. And we have to do that into a completely clean environment. And that clean environment might be Hyper-V. So we've got some people who've got up-to-date versions of Windows with Hyper-V included in the operating system. We've got other people with older versions of Windows. They're running VMware. We've got VMware also as our corporate virtualization system for our own private cloud. And we are using Google Cloud as our cloud virtualization platform. I'm not going to go into the ins and outs of Google Cloud, but I'd far rather be doing this on Azure, but that decision was already made. And those images have to be reasonably portable. So we may actually take a VM image and say, okay, that's got to go and go into a test environment. So I have to be able to take a developer's image and use it in there. And building this is painful, potentially. It took them 4 months to build a set of servers manually. It took me about 2 months to understand it, and then I built the same environment in an afternoon. Okay, so that was the degree of improvement we brought to the party. And the scope, what do we have to build? Well, we have to be able to build an AD test environment. In this AD test environment, we're probably going to run clusters, so I've got to create shared disks for clusters. So we do that with iSCSI because it's just easy in a virtualized environment. We need to put on the installation files. We then have to be able to build SQL servers for testing. We have to be able to cluster those SQL servers and build an availability group. We have to set up application clustering. And then we have to do all these things to the individual Windows servers. So features, services, firewall, PowerShell modules, various utilities. I got somebody on my team who doesn't like the Windows 8 and Windows 10 style shell that's on the standard server. So he wants an alternate shell installed on a bunch of servers. Okay, fine. Management tools. And then we have these things that are the underpinning for this manufacturing execution system. This stuff comes from GE, and there are about a dozen applications, and they're installed in different permutations. If I was doing this again from scratch, I would have probably might have tried to get some kind of repackaging solution in. But as the position that we started from, we basically said, no, we can't introduce a repackaging solution. So the response files for installing these applications will need to be updated as we go. So there are some things where we come along and we say, okay, so run setup with this response file, but, oh, hang on, before you run setup, you need to go into the response file and change these things. And then all the local configuration choices. So the first time we built a server, somebody complained that we hadn't actually set the owner of the server correctly. I mean, I don't know how many organizations really are bothered by who Windows reports its owner as, but somebody complained. So we took care of all those things. We standardized the time zone everywhere, and then we got told, oh no, if it's not in the UK, it needs to be on local time zone. Now, I joked about scope creep when I was talking about the title of this session, and this thing about how I stopped worrying and learned to love scope creep. Here's the thing. Normally, when you add stuff onto a project, you go, oh, there's more stuff to do, and it's getting later and later. Here, what we're actually saying is we're learning more about how these machines need to be configured. So this application doesn't work unless you turn such and such a Windows service on, and that service is normally disabled. So somebody's learnt that, okay, we'll put that into the configuration that we do. And the more we can gather that kind of information, the more we can get it in a single configuration, and we can make the configuration reliable. We can also test for these things. And I was in one session earlier where somebody was talking about pester tests. Well, I have pester tests for how my servers are configured at the end. I do something that I don't know anybody else who does, but there must be people out there who do this. I read various kinds of files. So in the case of DSC, you probably know you create a thing called a MOF file, and the MOF file's got the specification for what you can do. Well, MOF file's text, and if it's text, I can crunch it with PowerShell. So I read the MOF file, and I crunch the MOF file, and I go, okay, so it says, for example, I want this firewall rule turned on. So I know the firewall rule details, so I could write a piece of text, which is actually a bit of PowerShell code for a pester test, that says, here is how you test for all the things that are in the MOF file. So I've got something that converts my MOF file to pester. In fact, to give me an excuse to just go and see how my build is going, it's possible that that has actually built. But I'm coming back to the ISE here. It rebooted 8 minutes ago. That might actually be done. But I've got the one file that I forgot to open before the start. I've got this convert MOF to pester. So you can see these are bits of text that are actually going to be rolled into a file. And what I meant to go and open wasn't the thing to build it. This is the danger of doing a running commentary. But I'm going to back out of here at a rate of knots because I've forgotten where it actually writes these files, but we'll come back to that. Here, I've actually got the tests that were created just as you were all filing in when I started this script running. So you can see here is a pester test, and I always think that a useful way to actually try and look at your code is to collapse it. Okay, so you can see it assigns Z to the CD-ROM drive if there is one. It configured the audit policy. During feature installation and removal, it did these things. By the way, I get really sort of finicky about how I write my pester because I reckon it should read like an English test. So it did something or it has something, but that should actually make a proper sentence. And when the test runs, this will all come out nicely formatted because I've put lots of spaces in and laid it out accordingly. But I've got all those things so that when I bring this machine up, I can actually run that pester test and check, right, so did we remove SMB1? Did we remove the old version of PowerShell, the old version of .NET, etc., going down the list? Did we make sure we put the other things on? So you can see that I want the cluster admin tools on here, even though I'm not a cluster, I want to be able to administer a cluster. Okay, so I write those tests as part of this process. So we're constantly adding to the list of things that we're configuring and the list of things that we're checking. So the process is basically describe what we're going to have, okay? So here we've got the description for a server. So you can see what's its role, because that's going to select pieces of the DSC configuration. What IP address should it be configured with? How's the cluster set up? How's SQL set up on it? And even down here, how am I going to configure the virtualization side of it? So describe it. That description sits separate from the logic. Okay. The next bit is, to quote the obligatory bit of Star Trek, make it so. Somebody will point. Somebody was telling me that they were talking superheroes in one of the sessions earlier, and they got the superhero factor wrong. Somebody will point out, I'm sure, that's not truly Star Trek, because that's obviously Picard and not Kirk speaking, but we'll come to that later. And then the final bit is show that it's been done and how it was done. So this actually is the result of that Pester script running. Those of you who've worked with Pester, you might know that there's an option to say, save the results as an XML file. So I tell it to save the results as an XML file, then I import the XML and export it to Excel. Okay, so a properly configured server, these are all standard bits. A cluster node has that, and then these are parts of the build process. Okay, so feature installation and removal ensured that SMB1 is not installed, and so on. So we want to make sure that we can prove that we've done what we said we were going to do. DSC, just some stuff on DSC. DSC is desired state configuration. Occasionally I see people using DSC to kind of tickle one setting. Okay, DSC is really about the sum of all settings. It's state. It's not an individual parameter of state. So if you see DSC being used for just one thing, that's usually bad. The problem is that it remembers the last thing that it configured, so you can say, make sure the configuration is how you did it, how you were told to do it last time. And if someone comes along and says, oh, I'm going to run another bit of DSC that just turns a service on, then you've lost that history. So actually what you need to do is you need to say, right, on top of all the other things you did last time, you need to turn a service on. Okay, so you end up with this kind of, I've jumped from Star Trek to Tolkien, but one script to rule them all. In this environment, anything that involved sticking agents on the servers was considered bad. Anything that involved more servers, like DSC pull servers, was considered to be bad. And they got a PowerShell guy, me, to come and do the thing in the first place. So this was they kind of set the route we were going to go down as far as DSC. So we had a collection of servers, and the first thing I was presented with when I looked at the server was a bunch of the PowerShell that I went to run didn't work. I brought some useful DSC bits, and it didn't work because we were running PowerShell version 4. And if you compile a MOF with PowerShell version 5, and you try and run it on a PowerShell version 4 configuration manager, it just doesn't work. So very quickly, I said, right, we're going to not try and work with any version of PowerShell before 5. So there is some 5.0 and some 5.1 around, but basically it's PowerShell 5 everywhere. If you have to write DSC resources, if you've never written a DSC resource before, plead not to write the old style MOF ones, write the PowerShell 5 class-based DSC resources. They are at least one order of magnitude easier to write. Okay? I can produce those relatively quickly. It takes me huge amounts longer to do the other ones. And there are some things that you can do. I said that the compiled MOFs are different. There are actually more things that you can do, more ifs and fors and so on, in that configuration. So you do get to having a single configuration. The trouble is that when you build that single configuration, you've then got a very big monolithic DSC file. And that's why I talk about creating a monster. One of the problems, and I'll come back to this, is, well, okay, so it's that, you know, they have a saying in Ireland, if you ask for directions about the best thing to do is not to start from here. If you want to use PowerShell 5 to do your DSC configuration, you've got PowerShell 4 on your machine, and you've got to upgrade PowerShell, that makes the whole bootstrapping process a bit more complicated. But we figured out a solution to that. I'll talk about that on a later slide. And that was worth it to get rid of the others. The other thing is not so much a decision, but it was a guiding principle. All the time, keep trying to peel the parameters and the logic apart. Get the parameters in one file and then pass them to another file. That has been a mantra throughout. And again, we're going to see just how some of this looks in a second. So here is a kind of condensed version of the DSC file. So you can see it's declared as a configuration, and it repeats this node branch, okay? So it repeats it for all nodes where the node name specifies one we were passed as a parameter. So we can just build a single node if we want to. And then we can say, if its role contains domain controller, then do what you do for domain controllers. If it contains cluster, do what you do for clusters. If we've set a locale name, then do the stuff to set a locale. If the list of packages includes Notepad++, guess what we're going to do, okay? And then we might have an array of features to add, so for each one of those, we install the feature. And that's basically the gist of how this DSC configuration works. Now, usually when you see DSC configurations, you don't see these ifs and for loops and so on inside the configuration. It goes straight to configuring individual resources. But we've got this extra layer here. And then we can say, OK, so here's my configuration data. In the nodes part of the configuration data, I've got a node called DC1. It's going to be a domain controller. Packages includes bginfo and Notepad++, and the features to install. So you can work out pretty much what that's going to do. It's going to do the domain controller stuff, skip the cluster stuff, skip the locale, install Notepad++, install these couple of features. And in order to build the MOF files, we run baseline and we tell it that's the configuration data that we want. And it will spit out the names of the MOF files that it's built at the end. So I'm going to take those MOF files and feed them into that script that I showed you, convert MOF to Pester. So now when I'm done, I get a MOF file and I get a Pester tests file. Now, why is there a gap in here? Well, we'll see that in a second, okay, because I didn't quite get the build done. One of the things that we found when I first built this was this lived in a file, and there was other stuff around it in the file. And we decided it was easier to pull an awful lot of this out to a separate configuration file. So what we now do is we look for a file that's got an extension of config.ps1, and we basically add the configuration files from that config.ps1 into the list of nodes there. So I don't have to have all my nodes in one place. So we get these three core files. DSC baseline. Hang on, let's do escape. So DSC baseline, you might be able to recognize a little bit from what I just showed you, but here is the node all nodes commands. And you can see we've got steps that are specific to a role before we get started. So you can see we've got those in there. We've got stuff that's specific to our database. Sometimes we have to install .NET 3.5 and sometimes we have to remove it. We found that for speed, it was actually quicker to put .NET 3.5 in the standard image and remove it where we didn't want it than it was to add it when it was wanted. But this will add it if it's missing. And then we've got what we call the final items. So you can see for services to enable, add each one. Make sure we've got a private network, add firewall rules. We've got a couple of things called fix firewall rule because these were just doing bad things. And you can see this one's straight from the slide I showed you. So basically, we can say, go run this script, and this script will install Notepad++. Normally, you say, here is a package. If you've done anything with DSC, you say, here is a package, and basically go install this MSI file. Notepad++, you actually have to do slightly differently. So we've got individual script bits in here for telling DSC how to do all this. Now, I said there's about 2,000 lines of code in here. You can see the configuration there ends actually at 2,100 lines of code. And then there's another bit for converting things to Pester that also lives in here. So we've got that piece. Convert MOV to Pester, I talked about. PS1 file, incidentally, the MOV files that come out of there are typically anywhere between 1,000 and 1,500 lines. They configure anywhere between 70 and 120 items. Convert MOV to Pester, I showed you, and we basically have got some configuration-specific things that we build by looking at the MOV file. We've also got some generic ones that we just put on every machine. Then I have this thing called publish MOV and tests, which builds that configuration data that was on the previous slide and calls the other scripts. So it adds config.ps1 files to configuration data. If we've got certificates for the machine, we add the certificate to the configuration. I'm not going to go on a deep dive into certificates and securing MOV files, but suffice it to say, if you've got to put a password in a MOV file, you can encrypt it, and the way that you encrypt it is the certificate that contains the public key lives on the server that's building the MOV file. The server that has the private key is then able to decrypt that content. That means that I can actually put administrative passwords out as part of the process. So let's actually resume PowerPoint here. So those are the three files, or graphically, if you like. We've got the logic in one file, we've got the machine description in another, and out comes the machine-specific files. So when you come to build any kind of significant configuration, you find that the resources you've got for DSC they're a bit limited. There are a lot more available to download. The problem with the downloads is they don't always cover exactly what you want them to cover. So there's a cluster module, for example, but it doesn't create cluster groups. So I had to add something to create cluster groups. Sometimes they don't work in the right way. The one for SQL is a lovely one. It tries to log on using the username and password that you've specified if you want to create local SQL accounts. If it can't log on, it says, oh, there's something wrong with the password. I'll try and change the password back to whatever it says in the DSC file. So that can be a problem if the password expires and needs to be updated. Unfortunately, if you happen to be running SQL 2012, it will pass a secure string to, and instead of the password being set, for example, to password, it's set to the secure string encoding of password, and you can never log in again. Obscure bugs that you find doing this. Sometimes the resource doesn't exist, and there's no option but to create your own. Some of the resources I've created, I keep thinking I will do something about sharing, and some of them are so specific to one company that there's no point. So you have to get used to the fact that you're going to either have to write or adapt some of the DSC resources that are out there. It's not difficult. This is by no stretch of the imagination is this rocket science. However, you need to understand that there are going to be more states that you could start from than you thought there are. And I'll drill into this in a couple of slides. The code for doing it, basically, here's a class that says it's a DSC resource, and it's got some DSC properties. So we say that one is the key, one of them is not configurable, so it's one that we only get back when we test the resource. And then the get operation, so we can say firewall profile is the result of getting whatever the profile name says, and then we can send the pieces back. Test says, is the thing in the state that we want it to be in? So we do a test, and if the test comes back true, we're going to do the next piece. If the test comes back true, we're as we should be. If it comes back false, we're going to do the next piece. Now, that's not strictly is the thing in the state we want it to be in, but it's do we need to do other configuration? Okay. And then finally, we've got the set. So if the ensure value up there is absent, then we're going to disable it. And if it's not absent, then we're going to enable it. And you notice we've got lots of verbose messages because we need to see, as the information comes back from applying DSC configuration, we need to actually see what it's doing. So I talked about unhappy paths slide ago. So we say we want to prepare a disk, right? You've got a virtual machine that's been prepped for you. It's booting off drive C. That's fine. There's another disk attached to it. You want to make that drive D. So initialize it, format it, create a single partition on it that occupies all the space, format it, call it drive D. Oh, what if the disk's offline or read-only? Well, we fix that. So, and this is actually pretty much what my learning was. So the next thing you do is you then start working with a cluster, and you find that actually the disk shows as read-only or read-only if the other cluster node owns it. So you then have to do another check to say, is it read-only but owned by another cluster node? Because then we don't want to bring it online. What if it's already initialized but not partitioned? Because is your test going to work there? You go to format it. Oh, the CD drive is drive D. Okay. And the one that really threw me, because I thought nobody used master boot record anymore, so I expected GPT drives, and then it turns out that no, my friends in IT actually attach MBR formatted disks to cluster nodes, and so how you recognize a disk changes completely. So you have to go and do something else. And just when you think, oh, I can bet that drive 0 is going to be my operating system drive, drive 1 is going to be my OS, my data drive, drive 2 is going to be my cluster quorum disk, someone swaps drives 1 and 2 around. So don't ever assume that the drive ID will tell you anything at all about what disk you've got. Oh boy, just, that sounds so simple, and yet untangling those things probably took 2 or 3 days of solid effort just to get to the bottom of it. And just when you think you've found them all, something like this shows up, and you kind of go, what? The way I'm recognizing disks is all wrong because instead of being a GUID, it's something else? Anyhow. So, other pitfalls. The configuration won't start. When you go to apply a DSC configuration, it won't start unless all the resources that are referred to in that MOF file are present. So what you can't do, you'd assume you could write a MOF file that said, go install all these DSC resources, and then later down the file, it says, right, now use the DSC resources you installed at the beginning. You can't do that. It doesn't work. Okay? And so you can break things if you're... Oh, and the other thing is you can break things if you have multiple copies of a resource file. You get the thing the other way around when you're trying to compile a MOF file. If you've got 2 modules that define the same resource, you get a compile error. If you've got 2 different versions of the same model on the same module on the target machine, and you don't explicitly specify the version in the configuration, then you get a runtime error when you go and apply it. So our process was basically delete all PowerShell modules before you start, and then copy on all the PowerShell modules that you're going to need. Because that way we knew we only had one, and we also, although they'll normally install and they'll be under version number, we collapse things up, we get rid of the version number. That way, we know we've only got one version. And even then, we still occasionally slip up. So we put 12 modules on, 6 came from the PowerShell gallery, 6 homemade. We use about 45 different resources. And depending on exactly what the machine configuration is, between 15 and 20 script sections in DSC, which we could make into classes. So we got quite a lot there. We rolled our own for some extra disk things, the thing I was just talking about, and for firewall management. For clustering, there is a cluster module, but we extended it, and we also extended the existing ones for AD groups and users, because the built-in ones didn't quite do what we wanted to do. One for groups, for example, we just want to say, if I've said in DSC, put this user into this group, put the user in the group if they're not in there already. If I've said take them out, then take them out. If I haven't said anything about a user who's in a group, leave them alone. The default one likes to remove users unless you give it a complete and exhaustive list of who's in there, which kind of messed things up for us. Of course, a couple of ugly surprises, actually, that one, when we found that, in the early days, we found that the number of users in the local administrators group had gone down rather dramatically. I'll show you this in a... No, I won't show you that. But we have a very, very large number of local admins. I've never seen somewhere with quite as many local administrators as we have. So, bootstrapping problem. You think, right, I'll start a remote session and I'll kick off the installation of the new version of PowerShell in the remote session. No, you won't. It won't run. Okay. To upgrade PowerShell, we actually have to use a scheduled task to upgrade PowerShell. We had to make sure we copied the DSC and other resources on. We had to figure out a way of handling certificates. Now, if we work on Hyper-V, we mount the disk image, we copy the files in that we need, and unattend.xml schedules a script that bootstraps DSC. So I'm going to come back to my demo that's running, and you can see it says up here, new VHD will create, hang on, let's try doing that again. So new VHD will create a new virtual hard disk with that path. We've mounted that hard disk and we've copied just under 5,000 files to it. Because this is a domain controller, it's got all the installation files on it to build the rest of a test environment. So I used domain controllers in a test environment as kind of my every bit of infrastructure server, because it's a test environment. Obviously, you don't do that in production. Then we've put the DSC files on, and we've put an unattend file in there that will do all these things. So it says, enable the administrator, turn off the user account page, turn off the shutdown tracker dialog. Why Microsoft? Why have a shutdown tracker? I don't understand. And then down here, schedule the DSC bootstrap process to run after the first boot. So we can actually kick that off as part of installing a Hyper-V virtual machine. If the machine's pre-built, we basically make a connection to the C $share, copy the files over, and then run commands in a PS session. So we remote onto the machine to do that. And that bootstrap process, this is not really the full version, but basically if the version of PowerShell is less than version 5, then we basically kick off the installation of PowerShell. If we don't have a certificate set up, then we check to see if there's a certificate available, and if there isn't one available, we create one. And this little configuration here basically is what we need to apply that certificate to the local configuration manager so we can use it. Then we can basically say, export the certificate. So if the certificate's exported, we can then pull it back and use it the next time we build a MOF file. And then if we've got valid MOF files for this machine, get rid of anything that doesn't relate to this machine and kick off the DSC configuration. Finally, if there's a task for running this process, get rid of this task. And if we're pushing things out instead of building them from Hyper-V, we basically connect to a new virtual machine. We don't necessarily know its name when it's built, so we might use its IP address. We might have to specify credentials to make the connection. So we have to do some WSMan configuration to make that work. Check for the certificate. If there isn't a certificate, we copy files over and create a certificate and copy the certificate back. If it's an old version of PowerShell on there, we schedule that BootstrapDSC file to run, and we run it. So what's going to happen is we're going to kick the thing off. That will install PowerShell. That installation will cause the machine to reboot, and then when the machine reboots, it starts up as just like a Hyper-V installed one. Create MOF and test files using the certificate and copy them over. And if we didn't schedule the task, then we just run that bootstrap process. And at the end, we actually run something to get the state back. So my new virtual machine is built during this session. There it is. So I'm just going to let that connect like that. Not that this is slightly tense or anything. You are going to connect. There we go. So for reasons that I never understand, we use a standard thing. We have great fun with passwords. They're all well-known expressions from Monty Python. Just talking about Jaguar Land Rover briefly. Jaguar, as you probably know, is owned by Tata, so we have quite a lot of people from Tata Consulting Services who are rotated in from India. So they come over and they spend typically a year, and sometimes they get the visa renewed and come back for a second year. Trying to explain to people who didn't grow up in England why the password is, it wouldn't go voom if you put 10,000 volts through it, or something for which that is a mnemonic, it's always fun. So it's run for the first time. You can see I've actually added a PowerShell profile to there, so it's got the PowerShell in there, and what I'm going to do is I've got something called get DSC log, which will output as a grid view, and we can see what DSC did. So these are all the steps as we went through. So you can see it's set the meta configuration, which is the configuration of the config manager itself, and then you can see it's gone through and it's set audit policy for what we record system failures of, what we recall, so some of these need to be changed, and you can see that we've made a change to security audit policy for failure. We've made a change, no, we didn't need to change success and failure, we didn't need to change audit, we didn't need to change time zone, but as we come down here, we can see all the things that we have changed. Now this is a bit of a handful. So the other thing I've got here is export setup info. And this writes an audit, a simple 2-page audit to an Excel file. So it's now running a pester test. So you can see it's, go on, baseline tests is the common ones that are configured for everything. I'm hoping, if I've managed to do this right, we will actually get 1 or 2, I know there's going to be 1 failure in here to show that this is not, in fact we've got 2, even better. But there's one there that says the server should have been patched in the last 120 days. Well, this one hasn't been. So we flagged that as an error. Because I'm on a private network with this virtual machine and I haven't set the network very carefully, it also says it can't connect to all the other servers in the domain. But we've got a file that's written to the install share on this server. So if I go to instaps, no. That was trying to be too clever by half. Inject files. So it's actually written setup.xlsx there. So what I'm going to do is just copy that and bring it back to my machine. So we'll just stick it on the desktop here. So what does that tell me about setup? So you can see this is these are the pester tests, all nicely formatted. So the tests that we've passed are in green. The tests that we failed are in red, so I can just say, filter it down to the ones that failed. So you can see it hasn't been patched and it can't connect to domain controllers. That's because of the network. And then the DSC side, I've just taken the end set line from each of those, so we can see each of the things we've changed. So we've changed the admin user, we've renamed admin to H49, which was that strange account, changed the audit policy for failure all the way down, and these were all the things that we set as part of this. Now, in my PowerShell ISE here, I've got a rather more complicated audit. And this audit, you can see these blocks here towards the bottom of the window. You can see we get Windows features, we get services, we get local users. And a bit further up, we've got some more complicated sections for general system info, hotfixes, software clustering, and so on. And the diff file, actually, this diff operation compares to 2 different spreadsheets. So up the top here, I've got one of our production servers, and you can see at the bottom some of these tabs are highlighted in yellow. So let's go and have a look at the services tab. This service is different from the others because this particular service is configured to start manually, and that one's different on this box from anything else. And in fact, we can have a look and we can see that one's coming from a different path, or it's got a different path name. Because of how the VMware snapshot provider works, they always have a unique GUID here. And then these have got different startup modes. Now, I took that a step further. I talked about this thing of Doug Fink's. This is actually, would you believe, this Excel spreadsheet is designed to look like this. It's one of the widest spreadsheets I've ever built. Each row is a hotfix ID. The orange-coloured ones are ones that are installed, and it's unusual that they're installed. And the pink is basically where it's gone missing. This divide here is between 2 different factories. So these are all the factories in one place, or these are all the machines in one place. These are all the machines in the other. And when we talk to our IT friends and say, so you are patching the servers with consistency? And they say, yes, of course we are. We then come along and say, well, how come all these are missing from this server? And how come all those are missing from these servers? So that's part of that audit and making stuff work with Excel. So that kind of loops the thing round to infrastructure as a spreadsheet. So I think that's pretty much it. That last bit is part of this. If you can't show what you've done, don't bother. Okay? Show it, prove it, deliver it in the format that people actually work in, like Excel. Get as much as possible into that DSC configuration. Yeah, absolutely. And think of DSC not as a ready-made tool, but as a toolkit where you're going to have to bring something to the party. One of the major things was actually making sure the local configuration manager could run them off once we'd built it. That was probably as much as work as everything else. And often when things go wrong, you go, oh, there's something wrong with my code, something wrong with my logic. 90% of the problems we've found, we're actually putting the wrong parameters in. So we say, here's this big list of parameters, and we put the wrong ones in, and the server builds wrong because the code has followed the logic impeccably, but it's actually built the server wrongly because we gave it the wrong parameters. So that's about it. I do want to say a quick thank you to our sponsors. So there is a very quick thank you to our sponsors. And just looking at the clock, if you've got any questions, I think you're going to have to catch me outside, okay? But thank you for your time. Thank you for your attention. Thank you all for not leaving.